Hello people, we are again here to solve the problem of the day. Well, today we are having a detect cycle using DSU, that is disjoint set union. Let's read the question and try to see the approach. The question is saying, given an undirected graph with no self loops with V from 0 to V minus 1 nodes and edges E, the task is to check if there is any cycle in the undirected graph. Pretty simple problem statement. We will be given a graph in which we will be having an integer v, denoting that we are having nodes from 0 to v minus 1, and we'll be given the edges. Simple, right? And specifically in this question, it is mentioned that we should be using disjoint set union approach for solving this question. Let's see how we are going to approach this problem. Okay, the test cases are here again. Let's see. Taking this example up. As you can see, in this graph, there is one loop, right? There is one loop that is existing. That's this one. So eventually the answer has to be true. And in this one, you cannot find any loop of such kind. Thus the answer has to be 0, that there is no loop that is existing in this graph. The question statement is pretty simple. Let me quickly tell you a little about DSU if you don't already know it. DSU or disjoint set union is actually, you can call it as a data structure, or it is more similar to just like you have a stack and queues. It is not actually a data structure, but it is a concept. And once we use DSU in graphs, it makes many of the things very efficient. So first of all, in DSU there are two functions. First is find and second is your union. Correct. So what do we do in DSU actually? We make up sets. Okay, we make up sets, and the set is in form of trees. What am I saying? Let's see. Okay, assume this like these are a bunch of nodes that are given, and they do have some edges here. Correct. Now, if we need to create a DSU out of it, what do we actually need to do? Okay. Let's say you have two more data structures. Let's go with parent first. Okay, so parent is going to be an array that you have to make. What will it be doing? Okay, let's say we are starting with 1. If I give you this node 1 and I ask you what is a parent of 1, obviously you would say that 1 itself is the parent because we are not associating any node with it, right? So we can say 1 is the parent, right? Initially, if we see it like this, at 1th index, what will be the value? 1. That means 1 is a parent of 1. Now, if I take 2 and I make union of this, that means there was one set in which only 1 was there. Now I'm making up a set with another, you can say, node, and I'm making union of these two. So if I'm doing union, what will actually be done is either 2 will be made a child of 1 or vice versa. So here as the option, let me just make up this connection. I will introduce 2 as the child of 1. Fine. Now what will happen at the second index? What will be written? 1 will be written. That means if we are having 2 here, 2 is actually belonging to this set in which the parent node is 1. All right. And how are we going to know? How are we going to know that? Now we know what is the function of union. Whenever we keep on attaching the nodes to it, it will be making them either the children or the parent, right, of sets. And we can even take 2 trees. Assume this is one tree, correct? We have 1 and 2, and this union was there, which was 3 and 4. So 3 and 5, right? In which 3 was parent and 5 was child, something like that. Now, when we put union of these two, we just have to, make one thing as parent, another as child. And depending upon what is the optimal thing, you can study it in depth. If I have to make a set of it, it can look something like this, right? Now we know what union function is doing, correct? It is composing of sets. And what is the meaning of this find function? It will tell of which set you are belonging to, that node is belonging to, or what parent does it have. So if I say find 3 here, what is going to be the answer? After this union, what is going to be the answer? The answer will be 1. That means 3 will be storing 1, 5 will be storing 3. And eventually, okay, let me first tell you about 3. When we have find 3, what will we get? We will get 1 directly because it is attached to 1. 1 will be the parent. 1 will be the parent. Now if I ask about 5, does 5 belong to this row? What will be the answer? The answer that find will return is going to be 1. But how will find approach it? The function find will approach it by saying that 5 is having 3 as a parent. Once it will reach 3, it will see that 3 is having 1 as a parent. Then it will reach 1. Then it will see 1 is 1's parent. That means this is the point when your index and the node you are saving becomes equal. This is the point where you have to return in find. Okay, that means at this point you know that which what is the parent of that particular set. Done. Now again, okay, assuming this set was not made yet. This set was not made yet. Then if I ask you about this one, this set, now I'll say find 3. What will I get? I'll get 3 at this position. Okay. Now if I say find 5, what will I get? I'll get 3 because union is not formed and this is an individual set here. Fine. I hope now the terms find and union are clear to you and what are they doing, and parent you can form an array of that to keep a track of all the sets. Okay. So this was a little brief about DSU. How we are going to make use of it in our task, that is to find cycles. Assuming this is a random graph that I have taken, that is given to you as the question. Now what do we have to do? We have to compose these sets. Okay. Now let's say it is like this. Fine. So what will you do? You will start composing your sets. First of all, you will have a parent array in which every node is going to be their own parent because no set is made. Then you would start. Let's say we picked up this edge. Now we have to make up this set. Correct? 1 will be parent, right? Or 0 could be parent depending upon your choice. Then you need to keep on adding to this set. Okay, let's say we now picked up this edge. One more set created, right? Now, whenever we are encountering a new edge, that means now I have to include 4. Firstly, what I'll check, to what set it belongs. If it does not belong to the same set that I am in, that means I have to include it and I have to put union. So if you are here in this set and you are seeing 4 here, you see 4 is not in that set, not in the same set. That means what do you have to do? What do you have to do? You need to make up, okay, let me take this path only. Okay, you need to make up this set. That means that it will also be included like this, correct? Now this will be the set. Now again, this cell will be having one single parent. Let us assume that 2 will be the parent. And now this is the cell. That means it has expanded. Now, once we are here, we need to see that the set we are making, if it encounters any node that actually is making a loop. Because if you are here at 2, you will then check for 1 as well. If you're picking up this edge, you will first of all check what? You will first of all check that when we're taking this up, it is a new node. But once you are here, once you take up this edge, 1, 4, you will see that it is belonging to the same set. Once you get to this position, that means the cycle is present in the graph. And if you take up every edge of your graph and you do not encounter this situation, that means each and every edge actually may be belonging to separate sets. If that is the case, then there will be no cycle. If you encounter such condition, if you are here, if you come till this point, you can say that cycle is there and simply you can return true in that question, right? Pretty simple. By using find and union, it makes so many concepts really easier. Now we do have, different methods for doing the same thing. We can use hash maps, or we can use different approaches for finding out whether there is cycle or not. But DSU is found to be usually like most optimized approach. Let's see the code for the same. Okay, so here is the code. Let's quickly go through it. You can see this is the implementation of DSU, and here is the main logic of the question. We are simply making up parent and rank. Rank is there just to optimize your union function more. Okay. Now we are creating up a set initially for our implementation. Then I'm going through each and every edge. This loop is for picking up each and every edge that is given in the question. Now I'm just checking up. I'm finding out if that edge, that means if it is U to V, then if we are checking the same thing with V, we are checking the same thing with U. What we are saying, please find the set. That means what does find do? Find tells that what is the parent of that particular set. If the parent of both the sets are same, that means both belong to the same set. And thus, if that situation occurs, we can simply return 1. And if that is not the condition, we need to make the union. We need to compose them in the same set, right? And we have to go on further till our edges are exhausted, right? Pretty simple. Let's try to run this code. Okay, so here's the same code. Let's try running it. Okay, so it is giving the right output. Let's try submitting it against the test cases. All right. So it is passing all the test cases. So I hope you have understood the solution. And if you like the approach, surely comment that down. I'd be seeing that. And if you have any doubts, you can comment that too. We'll be responding to it. And do like the video and keep on solving POTDs.